Good morning, my dear students. Myself, Kausar Momin, 8th standard, subject Science, chapter number 5, Inside the Atom. I hope you all have understood which I discussed in last lecture. Today we are going to discuss a very interesting topic. Let's go ahead with our topic. Electronic configuration of element. As we have seen in last lecture, that with the formula 2n square we found in orbital structure the number of electrons 2, 8, 18, 32 and all. Okay, so all those concepts only we are going to continue with this topic. So please listen carefully and observe here in your textbook which I am reading. Okay, we have seen that 2, 8, 18, 13 electrons can be accommodated in the shell K, L, M and respectively, as we have seen in last lecture. Okay, this is the maximum capacity of that shell. Likewise, in the first shell, number of 2 electrons can be there. In second shell, only 8 electrons can be there. In third shell, only 18. Above 18, it is not possible. There will be no possibility of the 19th electron in that shell. Okay, so we can say that is the maximum capacity of that shells. The electrons in an atoms are distributed in the shells according to their maximum capacity. The shell-wise distribution of the electron in an atom of element is called as electronic configuration of that element. Whatever the capacity we have seen, that is 2, 8, 18, 32 as per their shell 1, 2, 3 K, L, M, and we can say. So whatever we are saying this numbering, this is nothing but we can say it as electronic configuration of that element. Electronic configuration of that element. Okay, each electron has a definite energy as per shell in which it is present. Energy of an electron in the first shell, which is K, is lowest, which is very lowest. So energy of the electron in the subsequent shells goes on increasing with the ordinal number of the shell. So very least energy will be there in first shell. Okay, how the number of shell are going to increase is number 1, number 2, number 3. Hence in the similar manner the energy of the electron will also increases. Obviously it is depend on the number of electrons. The electronic configuration of an element such that the energy of electrons together is maximum possible. Electron get placed in a shell accordance with the maximum capacity of electron shell in an atom in the increasing order of the energy. Let us now look at the electronic configuration of the elements. So in this table you can observe very nice table given over here. So very first column, atom symbol, electron number in the atom, distribution of electrons as per the shells K, L, M, N, and electronic configuration means whatever the K, L, M, N number of electrons are there, we have to write it with the comma. Okay, very first atom is hydrogen. Symbol of hydrogen is capital H. Electron number in the atom is 1, and shell, obviously this one is distributed with this only. Okay, so electronic configuration will be 1 only. Okay, next is helium. Symbol for helium is He. Electronic number in the atom is 2, so 2 will be come over here only. Now lithium, the electronic configuration is 2 itself. Lithium symbol is Li. Electronic number is 3. Electronic number in the atom is 3. Now you can observe here in this shell, in the K shell, the capacity is only of 2 electrons only. So out of this 2 electron, out of this 3 electron, we can write only 2 electron. We can take only 2 electron in the first shell. So Out of this 3 electron, we are taking 2 electrons over here. One is remaining, which is going to the another orbit, or we can say it as another shell, which is L. Okay, so hence the electronic configuration for the same is 2, 1. Okay, now next is carbon. For carbon, symbol is C and electronic number is 6. Now you only tell me how to write this. So the capacity of this first shell is 2. 6 minus 2 will be 4. So 4 we can write over here. Hence the electronic configuration is 2, 4. Please note it down in your book. Next is nitrogen. Number is 7. Symbol is N. First shell capacity is 2. Next we can fix 5. Hence electronic configuration is 2, 5. Please note it down in your book. Next is oxygen. Number is 8. Symbol is capital O. 2 is over here and 6 will be over here. So electronic configuration is 2, 6. Next fluorine, 9. 2 over here and 7 will be here. Electronic configuration is 2, 7. Next is neon, 10. 2 over here and 2, 8. So it will be 2, 8. Next is sodium, that is 11. 2 over here and what is remaining? 9. But the shell has a capacity is of only 8. So we can write 8. So 2, 8. How many remaining? Only 1. So 1 we can fix in the another shell. So your electronic configuration for the same is 2, 8, 1. I hope you all are understanding all these concepts. Next chlorine, 17. We can write 2, 8. How many remaining? 7. So electronic configuration is 2, 8, 7. Note it down in a book. Next is argon, 2, 8, 8. Okay, hence electronic configuration will be 2, 8, 8. Next is bromine, 35. Now here it will be 2, here it will be 8. So it is 10. 35 minus 10 is 15. Out of 15 we can write overall 15 over here only, because the capacity is of 18. So hence electronic configuration is 2, 8, 15. So in this way we can write the electronic configuration of these many elements. This is a part of your homework which you have to write in your homework book. Okay. The electronic configuration in the numerical form contains numbers separated by commas, obviously which we have seen in the above. Here the numbers indicated the electron number shells with increasing order of energy. For example, electronic configuration of sodium is 281. It means that total 11 electrons in sodium are distributed as 2 in shell K, 8 in shell L and 1 in the shell F. The electronic configuration of an atom can also be represented by shell diagram as shown in figure. Let me show you. This is the shell diagram. See, for hydrogen this is nucleus, and in first orbit only one electron is there because hydrogen's electronic number is 1. For helium, electronic number is 2, so we can represent this way. This dot represents us number of electrons. For carbon, 2, 4, that means first orbit 2 electrons and second orbit 4 electrons. For neon, 2, this 2 electrons, first orbit, and in second orbit 1, 2, 3, 4, 5, 6, 7, 8. Sodium, 2, 8, 1. 2 first orbit, 8 second orbit, and 2 will be in 1 will be in the third orbit. So we can represent through diagram also. So this is skeleton of electronic configuration. This is skeleton of electronic configuration which you have to draw. This is also a part of your homework. Okay, now you can make this type of diagram for these many formulas. As we discussed the theory in previous minutes, use your brain power and give the answers for the same. Think over here. Very easy concepts. You can give the answers for the same. If you are not getting answer, just WhatsApp me. I will give you the answer. Okay. The concept regarding valency of an element, chemical bond and compounds get clarified from electronic configuration. Atoms form chemical bonds by using electron of its outermost shell. Valency of an atom is determined by the configuration of its outermost shell. Therefore, the outermost shell is called as valence shell. Also, the electrons in the outermost shell are called valence electrons. Let me clear you this concept. What is over here? When a compound forms, when a compound going to form, how compound forms? Compound forms through an element. Likewise, we have hydrogen one element and oxygen another element. So we can say simply element will be single hydrogen and oxygen. Now we are having a chemical formula for water, that is H2O. This is a compound. This is a compound. Now I hope you all have understood the difference between compound and element. When the two elements gets mixed with each other and we are getting compound from the two elements. We are getting compound from two elements. Now how it is happening? What kind of reaction is going with it? Obviously some reaction is happening with it and we are getting H2O. H2O is of water. Now if you are going to come with its electronic configuration, so how it is going to combine with each other, how it is pairing with each other. So the pairing is likewise hydrogen. We all know the electronic configuration of hydrogen is one only. So this is the nucleus and one electron which is revolving around the nucleus, that is the first orbit is one electron. So what about oxygen? What is the electronic configuration of oxygen? Electron number in oxygen is 2. Suppose hydrogen is 1. I am drawing over here. Please draw this roughly diagram in your book. This is of hydrogen. What about oxygen? 8 electrons are there. This is nucleus. And this is first orbit 2 electrons. And in the second orbit 6 electrons are there. 1, 2, 3, 4, 5, 6. Okay, so to get any complete procedure, to complete the procedure, any of orbit, any of the outer orbit should complete its octet. Octet means in the outermost orbit there should be 8 electrons. Then only the compound form. Now you can observe here with this oxygen, 6 electrons are there in the outermost orbit, and with the hydrogen in the outermost orbit. Outermost orbit means whatever the outer orbit over there, that is outermost orbit. In the hydrogen 1 electron is there. In the oxygen 6 electrons are there. If you observe it here, octet is not there. That means 8 electrons are not there in the outermost orbit. So we need one more hydrogen for the same. That is here 1 electron is there, and this 1 electron will get paired with the oxygen. So we are having number of hydrogen 2. This one hydrogen and this another hydrogen. So we can say H2 and this is simply O. If this hydrogen is sharing this electron with the oxygen, this hydrogen is sharing this electron with the oxygen, and in the oxygen octet gets completed. with the oxygen octet gets completed and hence the compound form. This is the formation of chemical bond in the element to make a compound. So one hydrogen gets two hydrogen and single oxygen. And when the octet is going to complete it, when that means compound gets formed and we can say H2O. We can say H2O form, that is compound. Now all these things are happening due to outermost orbit. All these things are happening due to with the help of the outermost orbit. Okay, so whatever the outermost orbit is going on over there, so that is the outermost shell. The same outermost shell are called valence electron. The pairing which is happening with hydrogen and oxygen, the outermost electron in the hydrogen gets paired with the oxygen. So whatever the giving and taking over there in the with electrons with the outermost orbit. So that is the such type of electrons are called as valence electron. And whatever the outermost orbit, whatever the outermost shell, that is called as valence shell. Whatever the outermost shell, that is valence shell. And the number of electrons present in it in the valence shell, that is called as valence electrons. Okay. It can be seen that the valency of an atom is related to the number of valence electrons in that atom. So, first look at the elements helium and neon. Atoms of these gaseous elements do not combine with any other atom. These elements are chemically inert. It means that their valency is 0. Who is having valency 0? Helium and neon. This type of question can be there in your MCQ also. Which element has a 0 valency? So you should know the idea, you should know the answer for the same. Helium and neon has the 0 valency. Helium atom contains 2 electrons which are accommodated in the first shell. Obviously, helium has 2 electrons which are accommodated in first shell. Helium has only the one K shell that contains electrons, and same in the outermost shell. The electron capacity 2 and K shell is 2. This indicates that outermost shell of the helium is completely filled. It is said that helium has an electron booklet. The electronic configuration of the inner gas neon contains 2 shells, K and L. L is valence shell of neon. The electron capacity of L shell is 8 and stable. Whatever the outermost orbit has 8 electrons, that means the shell is valence. Valency of the shell is filled. Okay, completely filled. It is said that neon has electron octet. Argon is an inert gas having electron in the shell K and M. The electron capacity of the M shell is 18. However, in argon, there are only 8 electrons in the valence shell. So that means we can say there are 8 electrons in the valence shell of inert gases. That is electron octet. If the octet is there, then we can say that from this understood that valency is 0. If the electron gets completed with its octet, then there is no valency. If the number of electrons getting shared with each other of the elements, we can say valence electron. If they are completing their octet itself, then that means there is no valence electron. Okay, so we can say it as 0 valency. Okay, the electronic configuration of elements other than the inert gases show that they do not have electron octet or their electron octet are incomplete. Regarding hydrogen, it can be said that its electron booklet is complete. Okay, so one electron is there only, which I have shown you example also of water. I have taken the example of water, H2O form. Okay, atom of all the elements except inert gases have tendency to combine with another atoms, meaning that they have a non-zero valency. You have seen from the formulae of the molecules formed by the combination with hydrogen. Likewise, I can say H2HCl, that the valency of hydrogen is 1. Electronic configuration of hydrogen shows that there is 1 electron less than the complete duplex state. I have shown you the example for the same, so please don't confuse with it. If this paragraph comes in front of you, so just consider the example of water. I have shown you the formation, electronic configuration and formation of compounds with the elements. All the concepts I have cleared the previous only. Just read out this paragraph and keep the format which I have shown you in the previous notes. Okay, so this number 1 matches with the valency of hydrogen, which is also 1. Moreover, it is learned that the electronic configuration of sodium 281 has 1 electron in valence shell. So the valency of sodium is also 1. Because obviously this outermost orbit electron gets shared with the another element. Okay, let me clear you with the sodium. Sodium has 11 electrons. In the first orbit there will be a 2, second orbit there will be 10, 8, and in the outermost orbit 1 electron is there. So definitely with this orbit 8 electrons are there, so that means it is completing its octet and 1 is remaining in the outermost orbit electron, which is going to pair with the another one. This electron will pair with the another one. So we can say that this is valence electron. This is valence electron. Okay. So sodium is also 1 as seen from the molecular formula NaCl, NaH, etc. And it means that there is some relation between valency of an element and the number of electron in its valence shell. Okay. Now use your brain power and tell me the valency and valence of valence electron, electronic configuration of this concept we can clear with this table. Okay, so this table gives us the idea of molecular formula of compounds formed by the elements. We can write their valency, okay, electronic configuration also. So here you can observe that this is the element, this is the molecular formula of a compound, this will give you the valency, this your electronic configuration of that element, number of valence electrons, and this should be, we can write 8 minus the X factor, whatever you are getting you can write over there. Okay, so very first is H symbol, hydrogen, molecular formula of compound HCl, valency of the element 1. How valency comes 1? So hydrogen has 1, and what is the number of electrons in chlorine? Number of electrons in chlorine will be 17. So hydrogen has 1 and chlorine has 17. Okay, so we can make their configuration. So for hydrogen we can make this way structure 1 electron, and for chlorine this is nucleus, first orbit 2 electrons, second orbit 8 electrons, and in third orbit remaining, how many remaining? 7 electrons. 1, 2, 3, 4, 5, 6, 7. Now to complete this octet, chlorine needs 1 more electron. So chlorine is taking this electron for the sharing with, it is sharing 1 electron, hydrogen is sharing 1 electron with the chlorine, and hence it is making, they are making the chemical reaction and the compound forms. So how many numbers of electrons are going to share over here? Only 1 electron. So hence we can say valency of the element is 1. Valency of the element is 1. Electronic configuration of the element is also 1. Number of valence electrons also be 1. Okay. And this condition is not satisfied over here, because this condition will be is of X factor should be greater than or equal 4, but here X is 1, so that is why this condition is not satisfied over here. Now next example is of we are taking an element of chlorine. So again HCl. So here you can observe here valency of the element is 1. Here we have to write the electronic configuration of chlorine. So it is 287. Number of valence electrons. 7. Okay, and this 7 number is greater than that of 4. So we can write 8 minus 7 as 1. Now we have to make a compound with neon. Neon with hydrogen. So neon with hydrogen, there is no compound, there is no formation, there is nothing like HNA. So there is nothing like HNA, so no compound is there. Okay. Now next is we have to make a combination of hydrogen and chlorine, which is HF. Now do you have any idea about molecular formula for this HF? Chlorine has 9 electronic number is 9. So we can write its electronic configuration as 2, 8, 1. Sorry, 9 means 2, 7 only. Sorry, 9 means 2, 7. The electronic configuration is 2, 7. Now, number of valence electrons. How many number of valence electrons are over here? 7. Okay. Now, what about valency of the element? So here, hydrogen is pairing with this chlorine, so we can write 1 electron is going to share with this 7 electrons. 1 electron is going to share with this 7 electrons, so we can write over here 1 electron. Okay, so now you can subtract this 8 minus 7 again, so it will be 1 only. So number of valence electrons are 7. Now you have to solve the remaining for sodium, magnesium, carbon and aluminium. What you have to make? You have to make each element with the hydrogen. That means here it is written NaH, NaCl2, methane and AlCl3. So these are the compounds here. You just have to make their number of elements, valence electrons. Valence means the numbers which are sharing with the another element. The electrons which are going to share with the another element, that you have to write as a valence electrons. Okay. And in the electronic configuration, obviously whatever the number of the outermost orbit, that you have to write only. You have to see over there, that means while writing this column, the outermost the last number should be greater than the 4. Then only you can write it down. Okay. So please complete this table. This is also a part of your homework. This chapter is very important. You will have the theory part and in detailed structure of the atoms and all in your next level 9th standard as well as in 10th standard also the detailed theory is there. So for the same you should have the idea about this atomic structure, how the compound is formed, what is the valency, what is the outermost orbital shell, what is the outermost orbital number of electrons. All these concepts should be clear with you. Okay, so this is also a part of your homework. I have given you the